All right, what's up, guys? In this video, we're going to pick up some vector calculus, and we're going to evaluate another line integral here. So let's evaluate this line integral, 4x cubed ds, where c is the line segment from -2 to, from -2, comma, -1 to +1, comma, +2. So the first thing we need to do is to parameterize the line segment. So that's the first thing that we need to do. So remember, in our case, to parameterize the line segment, remember that's just going to be 1 minus t multiplied by x sub 0, comma, y sub 0, plus t multiplied by x sub 1, comma, y sub 1. And remember that t will be between 0 and 1. So in our case, we'll have r of t is equal to, looks like we'll have 1 minus t. And we'll take our x sub 0, y sub 0, so that'll be -2, comma, -1. We'll multiply that, or we'll add that to t multiplied by our x sub 1, y sub 1, which would be +1, comma, +2. And again, everything, or t is going to be between 0 and 1 as we parameterize this line segment. Be careful with your negatives. Just pay attention to your negatives. Make sure that you are good there. So it looks like if we do the work here, it looks like we'll get -2 plus 3t. And then it looks like we'll get -1 plus 3t. This gives us our parametric equations. X is equal to -2 plus 3t, and y is equal to -1 plus 3t. Why do we even need parametric equations in the first place? Well, remember, to evaluate the line integral in R2, given the line segment, remember, to evaluate the line integral is going to be f of x, comma, y ds. And it would be basically done the same way if it was in R3. It would just have an extra variable, so it would be x, y, and z. In this case, we're talking about R2. But the reason why we need the parametric equations is because, remember, for the line integral, it would be the integral from a to b, and it would be f of x of t, comma, y of t, multiplied by the square root of dx over dt square plus dy over dt squared dt. We know that the ds part, which is what you see there, the ds part is just all of that stuff, which is the dx over dt square plus the dy over dt square. Keep in mind that the formula may also be written a little differently. It'd be ds is equal to the norm. They may write it this way as well. It's just written a little differently in some textbooks. Your professors might write it a little differently. So just be aware of the different notations. I always like to point that out in any of my videos. You will see things in math written differently sometimes. And it doesn't necessarily mean that the way you learned it is wrong. It's just in math, there's times where things can be written in a variety of ways, and they're really saying the same thing. Okay, so if we go ahead and we find dx over dt, well, we're just taking the derivative of x here with respect to t, and we just get 3 dy over dt, same thing, we're just going to get 3 as well. So when we set up the integral from the line integral that we were given, then the line integral will essentially become now the integral from 0 to 1, and we'll have 4. And remember, what we do is we take our x, which is our parametric equation that we got after we parameterized the line segment, which was -2 plus 3t, and we'll stick that in. But you do need to remember that it is being cubed, so if you're not careful, you'll miss that. So make sure you put that in there. And then we'll have that all times the square root of 3 squared plus another 3 squared, and all of that is integrated with respect to t. Now, for the square root, which tends to give students a little bit of fear, and rightfully so sometimes, particularly with these line integrals when we parameterize a line segment, when we're evaluating a line integral in R2 or R3. The square root, a lot of times once you do it, it'll just end up, being the square root of some number, or it'll simplify, which we know is just a constant that can be pulled out. So it's not like you're going to have some crazy function or something like that under there. So don't get too upset about that. And as I get another sheet, we'll want to continue with the whole process. Sorry, my fingers are so big I can never get the paper correctly. Okay, so we know that if we do it up here, we got the square root of 3 squared plus the square root of 3 squared, because the ds part was dx over dt squared plus dy over dt squared dt. So this is basically the square root of 18. If we do prime factorization, we can write the square root of 18 as 3 times the square root of 2. Again, those are just constant, or 3 times the square root of 2 is just a constant, it's a number, so we can pull it out along with the 4. Now, what we'll need to do is we'll need to expand out the expression negative 2 plus 3t cubed. We'll need to expand that out. So I'm going to pull out the 4. I'm going to pull out the 3 times the square root of 2. And then the integral the limits don't change. It's from 0 to 1. But we'll need to expand out negative 2 plus 3t cubed. Okay, so, all right. So in that case, this looks like, keep in mind that this is just negative 2 plus 3t, or negative 2 plus 3t times negative 2 plus 3t times negative 2 plus 3t. I think this is going to give me negative 8 plus 36t. I'm trying to do it in my head. 18 times 3 is 54. So this would be minus 54t squared. Then it'd be plus 27t cubed. And then all of that is integrated with respect to t. Simplify that out. That's just some algebra. I'm not really going to go into all of that. You could check me on that, but I believe it's right. I kind of did it in my head. I don't want to have to write everything down. It's a bit of a waste of time. I believe that is correct. Okay, so with that being the case, we now have these constants out here. A lot of times what students end up doing, and you don't want to do this, they end up trying to do too many things at once. I'm not saying you can't simplify the constants on the outside here at the beginning. You can do them in whatever order you want to, but don't try to rush through things because it's going to create a bit of a problem. I'm not even worried about the constants right now. I'm just going to deal with the integral itself. So from 0 to 1, we'll be integrating negative 8 with respect to t. And I'm going to use the sum and difference rule for integrals. So this would be from 0 to 1. We'll be integrating 36t with respect to t. And all of this is being integrated from 0 to 1, t squared with respect to t. And then we'll also integrate from 0 to 1, 27t cubed with respect to t. And then, we'll take our constants that are out here, 4 times 3 times the square root of 2, and we'll deal with those in a little bit. Let me grab my calculator right quick. I just want to check to make sure my math is right for that. I kind of did it in my head, so I just want to make sure that I'm not wrong on that. 18 times 3 is 54, so yeah, so that would be right. Sorry, I just had to make sure that was correct. Okay, so let's just deal with each of these integrals. And again, the more you do this, the less steps you have to write, so keep that in mind. Okay, all right, so the integral from 0 to 1 for negative 8 dt, we're integrating a constant. It is negative, but we're integrating a constant with respect to t from 0 to 1. So that's just negative 8. Here, remember, 36 is a constant, so that would be pulled out. This will become t squared over 2, which you know reduces down to 18, and evaluate that from 0 to 1. That means this will be positive 18. Here, 54 as a constant can be brought out, so it'll be t cubed over 3. And if I remember correctly, if I do 50, that'll give me 18 as well. So that'll be evaluated from 0 to 1. So that'll be 18 as well, because remember that 54 divided by 3 is 18. So we'd evaluate that from 0 to 1. And then this one would be 27 is a constant times t to the 4th over 4 from 0 to 1. And that's going to be 27 over 4. And so what we'll get is 4 times 3 times the square root of 2. And then what we'll have is negative 8 plus 18 plus, no, I'm sorry, not plus 18, it's supposed to be minus 18, sorry. Pay attention to your sign changes, almost got me there. And then this would be plus 27 over 4. Let me write that one more time because I kind of messed up right there. So that's going to be 4 times 3 times the square root of 2. And this will be negative 8 plus 18 minus, because there's a minus sign. Sorry, I almost messed up there. And then this will be plus 27 over 4. Now, if we use PEMDAS rules, we'll take care of what's in parentheses first. So that's negative 8 plus 18 minus 18 plus 27 over 4. And you want to make sure you're using a calculator. Looks like we'll get negative 5 over 4. So make sure you use a calculator, check your answers. So you get negative 5 over 4. So then we'll just have a 4 times 3 times the square root of 2 multiplied by negative 5 over 4. So this just becomes negative to the side here. This just becomes 4 times 3 times 5 times the square root of 2 all over 4. Well, the 4's cancel out. So it looks like this would give me 3 times 5, which is 15, times the square root of 2. And it's going to be negative. So that's what we would get. And that would actually be the answer. But let me see what that is as a decimal. So negative 15 times the square root of 2 as a decimal is negative 21.21. So that would actually be your answer. So your final answer for this line integral, we were asked to evaluate the line integral of 4x cubed ds. And again, we wanted to evaluate our line integral here. We had to parameterize the line segment. And the answer is negative 15 times the square root of 2, or as a decimal, negative 21.21. I'm just going to take 2 spots after the decimal. You don't have to write down the decimal value. Most professors don't care about that, but that's how you go about doing it. That's your answer to this line integral. So that one was just one that's in R2. That one was maybe a little bit more involved. I'm pretty sure I was right on everything, especially with that simplified. You do have to be a little careful. I had to kind of do that in my head. I didn't want to write all that down. It would have took forever. But this is basically how you go about doing it. So make sure you pay very close attention to your sign changes. It almost got me there up there, so you got to be careful. And everybody does things differently. Some people simplify constants first. Some people don't. That's entirely however you want to try to do it. But as long as we're arriving at the correct answer, I guess it really doesn't matter what road you drive down. But this is the answer to this line integral. So I'll try to post one where we'll evaluate it in R3. So that's going to be your answer. Let me know if you got any questions. See y'all next time.